all. The agenda for this session is Numpy. Numpy is a general purpose array processing package. So it enables numerical operations. So we'll discuss all this in this session. Okay. So let's get started with the Jupyter Notebook. Let's create a notebook file. So here we have already created an untitled folder, right? So let's create here only new Python 3. Okay, so before we get into this Numpy, I already told you to install the Numpy package. So how do we install it? Just to give a recap, since it's a Python 3, say it's a Python 3, you have to use the pip3 install Numpy. Suppose if it is a Python 2, then you can use pip install, just pip install numpy. Since it's already there, we installed it already, so no need to install again. Okay, so once it is installed, this is how we import numpy numpy as np. This is a pseudonym. This is a np is a pseudonym. Okay, just run this. This is how we import the numpy. Okay, so let's get started with the numpy. So what is a numpy? It's basically arrays. Okay, so numpy is a general purpose array processing package. Array processing package. Okay, so it provides a high performance multi-dimensional array object. High performance multi-dimensional array object. It provides a high performance multi-dimensional array object. Okay, so what are the some of the advantages we can discuss are advantages. See, arrays can handle large data sets, handle large data sets. It enables faster calculations or fast calculations. And also it has wide range of functions which can be invoked easily. Okay, this is the definition. These are some of the advantages. So Numpy package is a very handy package. We can have different, it handles large data sets, it enables fast calculations, and also it has a wide range of functions which can be invoked easily. Okay, so as I said, this is how we import. Just run it. So let's just do one recap of list. Already we discussed list. How do we define square brackets? Some 1, 2, 3, 4, 5. Okay. So I'm printing this print list, and also I'm printing the type list. Okay. So it is printed and it's a list, right? So let's start with one-dimensional arrays. Arrays. So first, the way we can define arrays, first define the list and then convert it into array, or directly first define a list, then we'll see. First define a list. List is equal to same, just copy paste, and then convert it. See, since we have created a pseudonym np, now we have to invoke a function called np.array. Array is a function which converts anything into arrays. So we are calling this and importing, calling this array and inputting this list. Okay, and then just print it. See, it is converted into array. List is converted into array by inputting into the function array in numpy. Okay, so first we'll define the list and directly send that list by defining a variable. We send it into array, or otherwise we can do directly. What we can do is array is equal to np dot array. We can directly send this list into this function. Okay, and check same result. It gives the same result. Just check the type of array here. Just type of array. See, it's a numpy.nd array. Okay, so this is the type. But also we can check the dimensions of this arrays. Is we have a function. We have a method called endim. We have a endim inbuilt in Python. Let's do this. Let's call this array dot. This is how we call this endim. It gives the number of dimensions. Okay, so it's a one. Since it's a one-dimensional, so it is 1. And also we can check the shape. Shape of the array. Same way we can invoke the shape by array dot shape. Okay, array is a variable name and shape is an inbuilt one in Python. So see, it has 5, right? 1 2 3 4 5 elements, so it gives the 5. But also we can get the length of the array. For length we can use len, and we have to send array as input. Okay, so this is 5. So same as shape, since it's a one-dimensional, length and shape are same. Okay, next we'll discuss the essential difference between the arrays and lists. Let's discuss the difference between arrays and lists. Okay, let's define first. Let's start with array 1, which is np.array. Always you should call this number, this function, to make it into an array. So 1 2 3. If you just define this way, then this is a list, and then we are sending that list into array function to make it an array. I am defining another array name arr underscore 2, which is np.array square bracket 4 5 6. Okay, now what I'm doing is I'm adding these arrays and assigning it to a new object called arr. Okay, I'm adding this arr1 plus arr underscore 2, and I'm printing this array arr. So what should be the result by this? Let's check. See, it's basically adding the first element in the first array to the first element in the second array. So 1 plus 4, 5, 2 plus 5, 7, and 3 plus 6, 9. This is the array. How mathematical operations work this way in array. Suppose let's check the same mathematical operation, how it goes in list. 1, 2, 3, same. We'll define the same and do the same thing what we did in array. 4, 5, 6. Okay, we have defined two lists. Now I'm creating a list and adding these two lists, assigning it to a list plus a list underscore 2, and I'm printing this list. Okay, so what could be the result? See, this is a this 1 2 3 is there. At the same time, 4 5 6 also got appended. I mean it 4 5 6. See, basically to this list, this list got appended. This is how the mathematical operation works in list. So this is the essential difference. See, it is getting added here, whereas it is getting appended. So that's why arrays are very handy in terms of operations. Okay, so in list topic we have defined days, right? Days. So days list, we created a list, right? Monday, Tuesday. We'll do the same here also. Monday, Tuesday, Wednesday, Friday, Saturday, Sunday, right? Okay, so this is basically a list, right? Just check. Okay, so this is a list. Let's convert into array. So how do we convert? Pass this argument, right, into array. So days, let's assign to this array, days underscore array. I am passing the invoking the array function using np. Okay, so I'm sending the input as days. Now let's execute. Okay, so let's display the result. Same, but array is created. Let's check the type. See, it's an array. Now let's play around with the indexing part. So now I want, see, same we defined indexing in list, right? So the same way it also works here. So let's play around with that indexing part. Yeah, let's display the second index. So Wednesday. So since it always starts with 0, indexing 0, 1, 2, second index is Wednesday. And also slicing works same as this. So 2 to 5. So second Wednesday to 5. 5 is exclusive, right? 5. This is 5 is exclusive. So 0, 1, 2, 3, 4, 5. 5 Saturday is exclusive. And also steps, we can check the subsetting steps array 0 colon 5 colon 2. So basically we are selecting from 0th index to 4, Monday, Tuesday, Wednesday, Thursday, Friday at steps 2. So Monday, Wednesday, Friday should be the result, right? So Monday, Wednesday, Friday, right? So this is one-dimensional arrays. Let's go to two-dimensional arrays. 2D arrays. So basically 2D arrays also work the same way. Like let me define arr. I'm defining an array and period. Again, see this process repeats. You have to invoke the function called array through np. Open brackets. Now again, you have to define a kind of nested list here, since it's a two-dimensional array. So first you open brackets, square brackets, and then again you open the square brackets, define 0, 1, 2. So this is the first list, second is 3, 4, 5. Okay, basically this is a list for one first list, this is second list, and this is a whole. This whole is a nested list inside a list. Okay, list in lists. Now let's check the result. Okay, 0, 1, 2, 3, 4, 5. Okay, let's call all this what we did in here. See, we called endem, shape, length, etc. Let's do the same. Array.endem, array.endem. See, it's a two-dimensional array. This is two-dimensional, right? So we're getting 2. Let's check the shape. See, it's a two-dimensional. It has 2 rows and 3 columns. 1, 1, 2, 3. Okay, this is how we interpret. And also let's do length. See, the same length is something which it gives the first dimension of the shape. So it is 2, so it gives 2. Okay. It always length always gives the, remember, it gives the size of first dimension. Okay, same. Let's do some indexing here also. So I'm 0th index. Let's check what is 0th index. See, so this is 0th index. This is first index. Again, if I want 1, then what should I do? First, it belongs to 0th index, first 0, and then in 0th index, it is how. What is the index inside? So this is 0. This is 1, right? 1, right? I want 5. If I want 5, this is in first index, and in first it is 3 is 0. In first 3 is 0, 4 is 1, 5 is 2. Okay, same as what we discussed in list. Okay, not much complications. Okay. Now let's do some typical functions, numerical operations in Numpy. Okay, so let's start with arrange. We have a function called arrange. So what it does is, let's define this np.arrange. So first let's invoke, this is how we invoke arrange function. So you can give any number inside, you can give 10, 5, 2, etc. Let's give 5 and check what is the result here. Sorry, it's a giving error. So arrange spelling. Okay, I put double R, so it should be single. Okay, so it should be singular. Please make correction. So see, basically what it gives is if you enter 5, it defines from 0 to 4. If you give 10, so it gives 0 to 9. Okay, so 10 elements, first 10 elements including 0. Okay, now let's define let's give it to a variable. Let's define arrange underscore 1. Okay, now just print this. First run this and print this same. Okay, so it gives from 0 to 4. Like let's do some slicing here also. So we can arrange just to slice start. Let me define this in syntax. Start it, end before, again end before is an exclusive, and step. Suppose this is the syntax. Let's execute this arrange underscore 2 and defining a variable. I am invoking the arrange function. I am giving first start at 0, comma. I am giving the end before as 6, comma. I am giving steps as 2. Let's do this and print and let's check what is the result. See what is the 0th element here? 0 is 0. What is the fifth? Sixth is exclusive, right? It takes fifth. Fifth is 4, right? So 0 to 4 and I'm giving steps as 2. So it gives alternate results 0, 2 and 4. And also we have a function called dtype in Python. Gives the data type. Okay. So let's call this arrange underscore 1 dot dtype. Just checking the data type. It's a int, right? So first, what is arrange 1? It's 0, 1, 2, 3, 4, and it is in integer. It gives it integer. Okay, and also it's see, we did not have any constraints here. We directly define np.arrange 5. Suppose if we want to say it default takes int. Suppose if we want to give if we want to get float, then we have to define the constraint. How do we define the constraint? Float. Suppose if we want the float result. Okay, so let's check arrange. I'm defining a float underscore float. I'm invoking the function arrange. Okay, so let's give 5. If you give this 5 and check the result, the data type would be int. Now you wanted specifically dtype as float. This is how we give dtype is equal to single quotes float 64. This is how we give. Okay, now let's check the result. Arrange underscore float. See 0.0, 1.2.3.4. Okay, now let's check the data type of this arrange float. Arrange underscore float dot dtype. So this is how we define constraints and arrange. Okay, so we have in Numpy we have inbuilt functions such as ones and zeros, where we can define all ones. So let's do that also. Ones. I am defining a variable called. Sorry, this is opening unnecessarily. Okay. ARR ones we ONES is equal to, I am invoking the function called ones. So here you have to define how many ones you want. I am defining 2 by 2. Let's define 2 by 2. Okay, 2 by 2 should be given in this like this. Okay, let's define this. Let's print. Okay, see, this is how it created all ones 2 by 2 matrix, like 2 by 2. Suppose you can give any dimensions. I'm giving, suppose you can check with other dimensions also. Once 3 by 3, you can check with 3 by 3 also, and print the result. Okay, so this 3 by 3 is the same way. We have zero function like I'm defining area 0 is equal to, I'm invoking the function called zeros. Same way 3 comma 3, and again this should be squared. sorry, this should be in brackets. Okay, so let's print the result. See, all zeros, 3 by 3 is matrix is created. Okay, now we have a function called transpose, which it transposes whatever we define. So first, let us define a list and convert it into a Numpy array. So we have transpose. So first, let me write this transpose. Okay. So let me define the variable arr and invoke the function array. Okay, normal brackets and then square brackets. I'm defining 2 dimensions. Okay, so list inside a list. So 2 dimensions I'm defining always. So 0, 1, 2. Again, this is one list, and again another list I'm defining 3, 4, 5. So this is first list. This is second list, and I'm sending it into a numpy array. Gets converted into an array. Let's check. Okay, now I'll apply transpose function transpose. Now let me apply this function called transpose. Here I am defining an object called transpose, and we can directly invoke this transpose. Suppose ARR. Okay, so let's check the result. Let's display the print. Let's check the result. See, I hope you all know how transpose works. See, 0, 1, 2, 3, 4, 5. This 3 will go up, this 1 will come down, this 4 will go up, this 2 will come down. That's how it works. Okay, transpose. So that will be transpose. Now let's go to indexing. Okay, so see, just check what is ARR. We have defined ARR, right? So this is 0, 1, 2, 3, 4, 5. So I just want to try indexing with this array. I want to display the first first index in the first dimension and second index in the second dimension. Okay, so what it is displayed 5, right? So basically this is how it works. So first it is displaying the second row, since it starts indexing always starts with 0, second row and third column. This is how we interpret. Yes, right? Since indexing always starts with 0. Okay. So this is how we interpret. And also we can select all rows and one column. Suppose like comma, I'm selecting the all rows, left side is rows and right side is column, and I'm selecting the second index column. So what should be the result? So 2, 5, right? See, all rows, how many rows are there? 2 rows, and 2 rows are there, all rows. This first row should be displayed and second row should be, but not all columns. The only third column should be displayed. 2, 5. Okay, only this and this. The same way we can test with all columns and only one row. Suppose I want to display only one row and all columns. Just give semicolon like this. So what should be the result? 3, 4, 5. So only this, right? So this is the 0th index row and this is first index. Okay. So this is how indexing works. Let's go to Boolean arrays. Let me continue in the next video. Let me continue this with the next.